Hi, today we're going to be learning about a special group of 3D objects called Platonic Solids. Before we get onto Platonic Solids, there are a few things that you need to know. First, some of the words that we're going to be using in this lesson start with the prefix poly, which means many. For instance, polygons are two-dimensional shapes that are closed. For instance, over here I've got a two-dimensional shape and it is closed. You can see that there's no opening. All the sides join together and it's closed. Okay? It must have at least 3 straight sides, where a side is like this over here. That's a side, and they must be straight. It must have at least 3 angles. So this would be an angle where 2 sides come together. And it can't have any curved sides. So a polygon is a shape, a two-dimensional shape, which is closed, and it has only straight sides, at least 3 straight sides and 3 angles. Then regular polygons are special polygons because all of their sides are the same length. As soon as it says regular polygons, it means that all the sides are the same length and all the angles are the same size. For example, we have over here a triangle, okay, but if all 3 sides are the same length and all 3 angles are the same size, it's a special triangle called an equilateral triangle, and it is a regular polygon. Okay, then the next one is a square. If you've got all 4 sides the same length as each other and all 4 angles are the same size, it will be a square. If you've got a shape with 5 sides, where all 5 sides are the same length and all 5 angles are the same size as each other, then it is called a regular pentagon. If you've got a shape with 6 sides that are all the same length and 6 angles that are all the same size, then it is a regular hexagon. If you've got a shape with 7 sides, then if the sides are all equal in length and the angles are all the same size, it's a regular heptagon. If you look over here, pent means 5, hex means 6, hept means 7. Okay, next we've got a shape with 8 sides, which are all the same length and all the angles are the same size, is a regular octagon, where oct means 8, like an octopus. If you've got a shape that has 9 sides, where all the sides are the same length and all the angles are the same size, then it is a regular nonagon. So non means 9. And then finally, if we've got a shape that has 10 sides that are all the same length and the angles are all the same size, then it is called a regular decagon, where dec means 10, like in decade. Okay, so those are our regular polygons. You do get other regular polygons as well. This is just going up to 10 sides. Next, irregular polygons are shapes that do not have sides that are all the same length. For instance, if I've got a square over here, that is regular. But if the square is stretched so that these 2 sides are a different length to those 2 sides, it becomes a rectangle. It is no longer a regular polygon. Even though the angles are still all the same size as each other, the sides are not the same length. So it's not a regular polygon. So the sides have to be the same length for it to be a regular polygon, and the angles have to be the same length for it to be a regular polygon. If just the angles are the same length and the sides are not the same, then it's not regular. And or the angles are not the same size, then it's also not a regular polygon. It's an irregular polygon. So again, let's have a look at our square. If that square is squished over to the side to make a rhombus, so the sides are all the same length, the same as they were over here, they're still the same length, but now the angles are not the same as each other, then this is not a regular polygon. It's only regular if the sides are the same length and the angles are the same length. If your sides are different lengths, or if your angles are different, or if everything is different, then it is not a regular polygon. Okay, so those are our polygons. You get regular polygons, which have all the same length sides and all the same size angles, and you get irregular polygons, which have different length sides and or different size angles. Okay, now we're going to go on to polyhedra. Polyhedra is the plural for polyhedron. So you have one polyhedron and many polyhedra. A polyhedron is a 3-dimensional shape. For instance, over here I've got a picture of a cube or a box. Okay, so it's a three-dimensional shape. All the faces, which are the flat surfaces, so this is an example of a face on this particular polyhedron, all the faces are polygons. Now remember what we just learned about polygons. Polygons are shapes that are closed and they have no curved sides. So in a polyhedron, all of the faces are polygons, so there are no curved sides. Okay, all the edges, which is where two faces meet. So over here I've got an edge, over here I've got an edge, over here I've got an edge, and so on. So all the edges, like this edge over here, which is where two faces meet, are straight. So nothing on a polyhedron will ever be curved. And it has sharp vertices. Now the vertices are the corners or the points where three or more faces meet. So over here I've got a vertex. That's a point where these three faces meet over here. So that's what we call the different things in our polyhedron. We have the face, which is the flat surface. We've got the edge, which is the line where two faces meet. And we've got the vertex, which is the point where three or more faces meet. Okay, so now we're going to go on to Platonic solids. Platonic solids are a special group of polyhedra that have faces that are all congruent, regular polygons. Okay, so first of all, we've just learned what polyhedra are. Polyhedra are three-dimensional shapes that have polygons as their faces, and there are no curved surfaces or anything. But Platonic solids are a special group of polyhedra where all the faces are congruent, regular polygons. So first of all, they are regular. That means that on any particular face, all the sides around that face will be equal in length and all the angles will be the same size. We just learned what regular polygons are. Then they are also congruent, which means that all the faces on a Platonic solid will be identical to each other. Okay, so that's what makes Platonic solids special. You can get different kinds of polyhedra where those are not necessarily true. There are 5 different Platonic solids. We're going to go through the 5 Platonic solids and look at their different properties. The first one we're going to be doing is the tetrahedron. Okay, so let's have a look at what a tetrahedron looks like. This is an example over here of a tetrahedron. It looks like a pyramid, okay? And we are going to find the different properties of this tetrahedron. We're going to find out the shape of the faces. We're going to find out how many faces there are. We're going to find out how many vertices there are and how many edges there are. In order to do this, I'm just going to show you the tetrahedron like this so you can see more easily the hidden lines. So we can see it as a 3D object. Okay. So first of all, if we look at the shape of the faces. So here I have got a face. Now you can see that it is a triangle. Okay, now remember I told you that for Platonic solids, the faces are going to be regular polygons. So this is going to be a regular triangle, which is a special name. We call it an equilateral triangle. So all of the faces on this tetrahedron will be equilateral triangles, which are identical to each other, because remember, in a Platonic solid, the faces are all congruent to each other. So this triangle will be identical to this triangle, will be congruent. It's congruent to the one at the back, and it's congruent to the one that at the base over here. Okay, so that's the shape of all the faces in our tetrahedron. Now let's have a look at the number of faces. So let's go and count them. So I've got this one over here. That's 1. Then this is 2. Then I've got the one at the back here. That's 3. And then I've got the one over here at the bottom, which is 4. So there are 4 faces altogether. Now let's have a look at the number of vertices. The number of vertices are the corners, the points where at least 3 faces meet. So here is a vertex. Here's another vertex, that's 2. Here's another one, so that's 3. And 4 vertices altogether. Okay. Then the number of edges. Remember, the edges are the lines where 2 faces meet. So I've got an edge over here. I've got an edge over here. I've got an edge over here. So that's 3 so far. Then I've got a 4th one, a 5th one, and a 6th one. So there are 6 edges altogether in this tetrahedron. So a tetrahedron has faces that are equilateral triangles. There are 4 faces altogether. The number of vertices is also 4, and there are 6 edges. Okay, so now you're going to be doing the same thing for a hexahedron. A hexahedron looks like this. Now a hexahedron is also known by another name that you have probably heard, which is a cube. Now we're going to be finding the same information about the hexahedron as we did for the tetrahedron. So you need to find out what is the shape of the faces, what is the number of faces, what is the number of vertices, and the number of edges. Okay, now you're going to be doing this one yourself. You're going to go through and find all of this information yourself, but to make it easier for you, I'm going to show it to you like this so you can see all the hidden lines. Okay, so I'm going to give you 1 minute to work on this. Okay, so let's go through what you should have got for that. So first of all, the shape of the faces. You should have found that the faces are squares, okay? Because remember, Platonic solids have got regular polygons for their faces. So it's a regular shape with 4 sides. It has to be a square because all the sides have to be the same length as each other and all the angles have to be the same size. Okay, so they are squares. Then the number of faces, let's go through and count the number of faces. So I've got this one over here, that's 1, 2, 3, 4, 5, 6 faces altogether. So you should have had 6 faces. Then the number of vertices, we've got 1, 2, 3, 4, 5, 6, 7, and 8. So there are 8 vertices altogether. And then the number of edges, over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So the number of edges is 12. So that's what we should have got for the hexahedron or the cube. The next one we're going to do is the octahedron. Okay, so octahedrons look like this. We're going to find the same information about the octahedron, and again I'm going to show it to you like this so you can see the hidden lines to help you. Okay, so I'm going to give you a minute for this one as well. Okay, so let's go through and see what you should have got for that. So first of all, the shape of the faces, just like with the tetrahedron, they are equilateral triangles. The number of faces, if we count them, you have 1, 2, 3, 4, 5, 6, 7, and 8. So there are 8 faces altogether. The number of vertices is 1, 2, 3, 4, 5, 6. There are 6 vertices altogether. Then the edges, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So there are 12 edges altogether. Okay, so that's the octahedron. Then we've got the dodecahedron. This is what a dodecahedron looks like. Okay, you're going to find out the same information for the dodecahedron as you did for the other Platonic solids, and I'm also going to show it to you like this so you can see all the hidden lines to help you. Okay, so I'm going to give you 1 minute for this one as well. Okay, so let's go through that. So first of all, the shape of the faces, they are regular pentagons. Then the number of faces, if we go through and count, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So there are 12 faces altogether. Then the number of vertices, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So there are 20 vertices altogether. And then the number of edges, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. So the number of edges is 30. Okay, so that's the dodecahedron. And then the last one is the icosahedron. Okay, so the icosahedron looks like this. Okay, and we're going to find all the same information for this one as well. So we're going to find the shape of the faces, the number of faces, the number of vertices, and number of edges. And again, I'm going to give it to you like this so you can see all the hidden lines to help you. So I'm going to give you 1 minute for this one as well. Okay, so let's go through that. So first of all, the shape of the faces. All of the faces are equilateral triangles. The number of faces, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So there are 20 faces altogether on an icosahedron. Then the number of vertices, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So there are 12 vertices altogether. And then the number of edges, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. So there are 30 edges altogether on an icosahedron. Okay, so let's quickly go through each of those again. So the tetrahedron has equilateral triangles for the faces. There are 4 faces altogether, and the number of vertices is 4, and the number of edges is 6. The hexahedron, or the cube, has got square faces. It has got 6 faces altogether. The number of vertices is 8, and the number of edges is 12. The octahedron has got equilateral triangles for faces. It has got 8 faces altogether. There are 6 vertices and 12 edges. And then the dodecahedron has got regular pentagons for the faces. There are 12 faces altogether. The number of vertices is 20, and the number of edges is 30. And then the icosahedron has got equilateral triangles for the faces. There are 20 faces altogether. There are 12 vertices and 30 edges. Now I just want to point something out to you quickly. Tetra means 4, and there are 4 faces. Hex means 6, just like in a hexagon, and there are 6 faces. Oct means 8, and there are 8 faces, just like an octagon or an octopus. Dodec means 12, and there are 12 faces, and icos means 20, and there are 20 faces. So the prefix for each of these tells you how many faces there are in each of the different Platonic solids. And those are all the Platonic solids and their properties. Now that we've learned the concepts in this lesson, it's important to practice, practice, practice. If you haven't already got the worksheet that goes with this video, you can find it by clicking on the link in the description below. The worksheet comes with an extra exercise full of questions for you to work on to master the concepts covered in this lesson. If you found this video helpful, please hit the like button so that others can benefit from it too. Also, be sure to subscribe so that you can easily find my other lessons, and hit the bell so that you will get notified about lessons as I upload them.